See, if you see yesterday's class, most of the people thought that, so it's very easy, sir. Only we explained about only RTV, RSV, static EMF, dynamic EMF, and because of RTV variation, static EMF is induced. Because of RSV variation, dynamic EMF is induced. Direction of static EMF is given by Lenz's law. Direction of dynamic EMF is given by Fleming's right hand rule. In Fleming's right hand rule, thumb means direction of motion of the conductor, forefinger direction of magnetic field, center finger direction of EMF or current. Similarly, I explained about Fleming's left hand rule also, by using which we can find out force experienced because of motor action. Those are very simple things, guys. Okay, people, you may think that it's very simple like that. No, actually, I did not start transformers subject really. I just what do you say? We just made some warm up before doing exercise. We used to do warm up, no, like that. Simply we did warm up only. So from today onwards, I'm just going to start transformer subject. So in the meanwhile, some previous gate questions also I'll be solving. Okay, guys. Okay. Let me start. I think this slide is completed, no, yesterday. So what about, I think I explained definition for transformer and working principle of transformer, right? Yeah, thank you, guys. So yesterday, to be frank, guys, you don't know, I was facing very big problem because of this cursor. See, I don't know how many of you observed. If I write on the screen, okay, I did not write well because of the cursor problem. But now, because that problem was overcome, now I can see. See, if you see here, let me simply take some color so that I can some underline. I mean, in this slide, let me give important points. I don't know. It's transfer slide device which transfers what, guys? It transfers what? Power. See, like this, whatever yellow mark is there, underline. I just underline it. With this clarity, yesterday did not came because of this cursor rule. Okay, no problem. I just overcome that problem, guys. Now, in this slide, the transformers transfers power is very important, and working with what I said, Faraday's law of electromagnetic induction. Okay, or simply we can write as mutual induction. Okay, guys. Now let me start. Let me go for second slide. Before going to second slide, can you please tell me why transformer can be called as single excited device? Can you please tell me first of all what is the reason why transformer called as device is not necessary for us, because we are technical students. We are not bothering about English, all those things. Generally, people used to say if machine, I mean, suppose in transformer we don't have any rotating parts. If rotating parts are there, that can be called as machine. But whereas in transformer, since we don't have any rotating parts, we'll call it as a device. It's not a compulsion that you should use device only. You can use machine also. Okay. Yes, you can call it as machine also. No problem, guys. Now, what I said, tell me what is the reason why transformer can be called as single excited device? Very simple. See, I'm just explaining here. Please, everybody. Yeah, very good, guys. One supply. Very good, Vishnu. See, I am just giving only one source. I mean, I connected only one external voltage source. Please try to see on the screen, everybody. Okay. So I just connect only one external voltage source. I think a time variant voltage source. Because of this time variant voltage source, it will take some current. So that current also I can say that time varying current. Because of time varying current, some flux will be produced in transformer core. So we'll see about this direction, all those things today. So that flux is time varying flux, and conductors are stationary. So rate of change of flux linkage will be there in primary side. How can you say that? You know, right? Yesterday I told that rate of change of flux linkage, how it is happening, guys? I told you E1 proportional to G by dt of what I said, N1 into pi, no? Okay, N1 into pi. Because I'm just discussing about primary side, so number of turns are nothing but N1. N pi means what I said yesterday, flux linkage. Rate of change of flux linkage is there because pi is time varied here, EMF is induced here. Okay, guys, same flux is going from primary side to secondary side, links with your secondary winding also. Here also, rate of change of flux linkage is happening. How means see, E2 proportional to what, guys? You know already, d by dt of what, ma? N2 into pi, no? Number of turns, how much in secondary side? N2, no? So here also rate of change of flux linkage is happening, EMF will be induced. Okay, guys. Now tell me, in primary side also EMF is induced, in the secondary side also EMF is induced. Okay, guys. Tell me, because of only one voltage source? No. You please try to understand. E1 is due to this flux pi. E2 also is due to this flux pi only. But this flux is due to current flowing in primary winding only. And this current is due to voltage source only. I am connecting only one external voltage source in primary side. Okay. So because of that voltage source, EMF into the primary side as well as the secondary side also. That's the reason why we can call transformer as a single excited device. Okay, this only I had given guys here. If you please try to see your note, transformer is a single excited device. What is the reason? Since by using only one external voltage source, okay, both windings. If you take example 2-winding transformer, primary and secondary. If you take a tertiary with 3-winding transformer, so their primary winding, secondary winding, and tertiary winding, three windings also EMF will be induced because of only one voltage source which is connected across a primary side. Is it clear, guys? So any number of windings can be energized by using only one external voltage source. That's the reason why you can call transformer is a single excited device. Is it clear? First point, everybody? So please respond. Please respond. Is it? Please try to respond. Is it clear? First point. If you have any doubts, please try to ask me. Okay, guys. Next, let me go to second point. Tell me, can I call transformer? Yeah, thank you, ma. Thank you, sir, Krishna. Okay. Can I call transformer as a constant power device? Why means ideally how much power you are giving input to the transformer, same power we should get at the secondary side also. Okay, no doubt practical some loss will be there. That is different case. I am asking ideally there is no change in power from input side to output side. That's why transformer can be called as constant power device. Okay, guys. Tell me which type of supply we will be giving to, which type of power we will be giving to the transformer. Is it active power or reactive power or apparent power? Everybody, anybody? Which type of power will be transferred by transformer? Yeah, Vishnu, active. Very good, ma. Very good. Active means you might don't know. No, the active power means P, nothing but VI cos pi. Okay. Whereas reactive power means what here? VI sin pi. Whereas apparent power S means what I can say? V into I, something like that. Okay. Okay. Now tell me, I'm asking here one simple question. Please try to understand. Transformer transfers which power? Transformer transfers which power? Active power. But there is different case. I'll tell you in future. But transformer rating will be in it's a transformer rating will be in VA or KVA, not in watts or kilowatts. Tell me guys, what are the units for this active power? Kilowatts. What are the units for this reactive power? kVAR. What are the units for this apparent power? I can say kVA. Transformer transfers I can say active power, but transformer rating will be given in a kVA. That I'll give explanation in future. Okay. Now, as of now, please try to just confirm your confirm this point. So transformer transfers which power? Active power. Nothing but it transfers kilowatts. Okay, guys. Right. So since there is no change in power from input side to output side, ideally I can call transformer as a constant power device. It's a very simple point. Everybody can understand. Okay. And what about the third point? Can I call transformer as a constant frequency device? I think yesterday only I had given explanation. Because while transferring power from one side to other side, just try to understand there should not be change in the frequency level. Because suppose let us assume that here voltage source is having frequency F, okay, and whatever the supply you are getting, whatever the voltage you are getting at the load, that load also should be having same frequency F only. Yesterday I told guys, what will happen if a frequency changes? I'm expecting an answer from you. What will happen if frequency changes from primary side to secondary side? Everybody, please tell me what will happen. Yeah, very good. Here end loads will get damaged. Very good, Johar. Okay, very good. So that means transformer is a constant frequency device. Okay, is there any doubt in this point? Yes. Okay, first 2 points are covered. Now tell me guys, can I call transformer as a constant flux device? Please tell me. Can I call transformer as a constant flux device? Please respond. Yes. Okay. Before that, please let me see this point, guys. I'll give time to you. Don't worry. Transformer is a constant power device. Reason means since input and output power is same, that is okay. And tell me, I told transformer is a constant frequency device also. What is the reason? No change in frequency from primary to secondary side. That's the meaning. Now tell me, what about fourth point? It's very, very important, guys. Here some people are confusing. Let me explain clearly. So tell me why transformer can be called as constant flux device. Okay, some people are thinking constant flux device means this constant term they are taking wrongly. Some people constant means they'll think that that flux is DC flux. It's not DC flux. Don't confuse by saying this term constant. Is it clear, guys? So tell me, DC flux means time invariant flux. You know, in a relative time variation in transformer, conductors are stationary. Magnetic field is what? Time variant to time invariant. Please respond. Please respond. In transformer, flux is time variant, time invariant, time variant. Very good. Time variant means what is the other name for this time varying flux, guys? Can I call it as AC flux? Anjana Suresh, can I call it as AC flux? Yes, very good. But so it's nothing but AC flux only here. But by saying this constant, don't confuse. We are using in transformer core, flux produces the AC flux only, time variant flux only. I can say like this, pi equal to, it will be like this, pi m sine omega t. Okay, like this. Here pi is what here? It's type of flux. It's a time variant flux only. Nothing but, or I can say AC flux only. AC flux only. Then tell me why I am calling it as constant flux device. Anybody? Anybody tell me why I'm calling it as constant flux device? What is the reason why I'm using this word constant? Why I'm using this word constant? So I think it is there in your bracket. I given explanation clear in bracket. Magnitude, very good, very good. See, in transformer, guys, what is the formula for EMF? I'm just writing here. Please try to see what is the formula for EMF. E equals to 4.44 n pi m into F. This derivation, I think we'll see today only if time permits. Okay. So tell me, in this EMF equation, is actually in this EMF equation of transformer, whatever pi m means what, guys? It's nothing but maximum value of flux, or I can say peak value of flux. It's nothing but maximum value of flux, maximum, or I can say peak value of flux, maximum, or I can say peak value of flux. Okay. So why I'm using this word constant means, so if you see throughout operation, irrespective of load, it may be, no load, it may be light load, it may be, it may be half load, whatever. Irrespective of load here, so we'll maintain core magnitude of maximum value of core flux. That flux only I'm calling as pi m. Please try to understand, magnitude of maximum value of core flux, nothing but pi m. That value will be maintained constant irrespective of load changes. Why I'm just maintaining a core flux constant? How we have to maintain core flux constant? All those things we'll see. It will come in future. Okay, guys. So now tell me, is it clear this point? Is there any doubt in this fourth point, guys? So I had given explanation also. Reason, magnitude of maximum value of core flux, magnitude of maximum value of. You should write it as of here. Please, yeah. Magnitude of maximum value of core flux is constant irrespective of load changes. That's the reason why you can call transformer as a constant flux device. Is it clear? Why I'm calling it as constant flux device? Very good. Since magnitude of this magnitude of pi m is maintained constant throughout operation. If it is a 20 milliweber, that I'll be maintaining constant irrespective of load changes. That's why I'm calling it as constant flux device. I'll tell you why we have to maintain core flux constant, how we have to maintain core flux constant, all those we'll see in future. Okay, guys. So I think fourth point is clear now, right? Now tell me. So what about fifth point, guys? Can I call transformer as a phase shifting device? Yes. Can you please give me the reason why I can call transformer as phase shifting device, please? I'm expecting an answer from you guys. Why transformer can be called as phase shifting device? Phase shifting device, please try to see. Please tell me. Answer, please. I'm expecting an answer from you guys. Right, tell me. So please tell me, what is the reason why you can call transformer as phase shifting device? Lenz law, it obeys Lenz law? No, it's not exactly because of Lenz law. No, please, any other answers? Indirectly, that answer also okay. That answer also can be, we can take that answer also considerable. So main reason, guys, I'm asking, main reason. Okay. So what is the main reason? Anybody? Yeah, okay, let me see. Please try to see this figure, guys. Primary and secondary voltage phase shift of 180 degree. Very good, Sanju. Very good, Sanju. Very good. See, I think today only we'll see, if time permits, we are going to see vector diagrams also. There we'll see, please everybody on the screen, ma. Prime input voltage means what is this one? I can take it as a V1, no? So please tell me what is the input voltage nomenclature here? V1. What is the output voltage nomenclature? V2. Okay. So between V1 and V2, we are going to have 180 degrees phase displacement. That how it is coming, all those things we'll see. Okay. So since a transformer offers 180 degrees phase displacement from input side to output side, that's the reason why you can call transformer as a phase shifting device. Not only transformer, any machine, any device which offers 180 degrees phase displacement from input side to output side, that device can be called as phase shifting device. Is it clear? So what is the reason why we are calling it as phase shifting device, guys? Everybody, angle between input voltage and output voltage, V1 and V2, angle between V1 and V2 will be 180 degrees. That I'll show you. Okay. Ideally, angle between V1 and V2 is 180 degrees. That's why we can call transformer as phase shifting device. Very good. Is it clear? Everybody, please respond. Please respond. Is it clear? Okay, Sanju. Thank you. Next, so I think we completed the phase shifting device. So I have given reason also, guys. It offers 180 degrees electrical. PD means phase displacement. Don't confuse by seeing this PD word. Okay. It offers 180 degrees phase displacement from input side to output side. That's the reason why you can call transformer as a phase shifting device. Okay, guys. Now, can you please tell me, can I call transformer as a coupled circuit? Yes or no? Yes. Very simple reason. See, if you take this 2-winding transformer, guys, which you are able to see on the screen, tell me, do you have any electrical connection between primary winding, secondary winding? Please answer. Do you have any electrical connection between primary winding, secondary winding? No. Very good. So then let me ask one more question. If they are not electrically connected, so here in primary winding, EMF induced means it's very common sense that it is connected to voltage source. That's why it will take some current. So flux will come. So EMF will be into the primary winding. So because of the source, it's happening. Now tell me, in secondary winding, how EMF is induced in secondary winding? Do you have any source here? Please respond. Do you have any source secondary side? No. Very good. Then how E2 is induced? E2 is also because of this pi only, core flux only. But whereas this pi is due to current flowing in primary winding. Very good. That means in 2-winding transformer, if you take, though 2 windings are electrically isolated, but they are magnetically coupled. Magnetically coupled means what? Flux linking with the primary winding as well as with the secondary winding. Magnetically coupled means you should see flux term. Flux is linking with the primary winding as well as with the secondary winding through what? Through transformer core. Through transformer core, I can say. Through transformer core. Okay. Right. So that's the reason why you can call transformer as coupled circuit. Okay. Is it clear, everybody? Respond, please. Yeah, very good. So I give reason, guys. Yes, coupled circuit means what is the reason? Since windings are electrically isolated but magnetic coupled through transformer core. Okay, guys. Now, can I call transformer as energy conversion device? Everybody, please respond. Can I call transformer as energy conversion device? Be careful. Tell me, can I call transformer as energy conversion device? Yes or no? Yes. How, guys? Can you please tell me what is the reason? So those who told answer yes, for them I am asking one more question. Tell me, what is the input energy of your transformer? I am asking, what is the input energy of your transformer? Electrical or what? Mechanical or magnetic or what I am asking? Electrical. Very good. What is the output energy of transformer? Once again, guys. Output energy of transformer once again. Electrical only. Yeah, very good. Somebody told mechanical. Kya hua bhai? What happened? So transformer, right? So input is electrical energy, whereas output is also electrical energy. That means there is no energy conversion. If you see externally, yes, input energy is electrical, output energy is also electrical. Therefore, externally we cannot call transformer as energy conversion device because both input and output is electrical. But if you see internally what's happened, that is very important, no? Internally. Yes, we are giving very good, very good. Electrical to flux to electrical. Thank you. Very good, Thomas. Electrical energy are given to the transformer, which is going to convert into flux. Flux means what here? Magnetic energy. Okay. Once again, magnetic energy is converted to what? Once again, electrical energy. So, if you see internally, energy conversion is happening. How? Electrical to magnetic. Don't say mechanical. It's a magnetic. Electrical to magnetic. Magnetic to electrical. Is it clear? Electrical to magnetic. Magnetic to once again electrical. So internally, energy conversion is happening. That's why you can call transformer as energy conversion device. Yes, we can say, but don't forget to place that internally word. If you forget to place internally word, you will take it as external. By default, people will take it as external. That statement becomes wrong. So please, if you see here, I clearly mentioned, yes, please try to see. Yes, is the energy conversion device. Okay. So please here I should write, as I said, see, some people see just now on I also, it's energy conversion device. You please indicate this word, ma, internally. This word is very important, ma. Please note down. This term is very important. Energy conversion device internally. Since electrical energy is converted to magnetic energy, once again magnetic energy is converted into electrical energy. Okay, guys, right? So if you want, you can give one. You can write one more point here for the regarding 7th point only. In bracket, you can note down. What is that? 7th point correspondingly, I'm just giving one more point, guys. What is that? Externally, transformer cannot be called as energy conversion device. Externally, transformer cannot be called as energy conversion device because input and output both are what? Input and output both are electrical. That statement, if you want, you can note down. Otherwise, it is enough. Okay. Can I call transformer as a negative feedback circuit? Yes. Okay. Reason is because of Lenz's law. That Lenz's law we'll see today only because of Lenz's law. Okay, guys. So can I call transformer negative feedback circuit? Yes. Reason is because of Lenz's law. Okay. So please, is it clear, everybody? Is it clear, everybody? Please respond. Is it clear? Is it clear? Very good. Very good. Now I'm just giving time to you. Please note down this slide. If it is completed, please try to let me know. After that, I'll go for the next one. Okay. In the meanwhile, let me erase whatever I wrote in between here. I wrote something right here. So if you want, I can keep it as like otherwise let me remove all those. Let me erase all those things. Okay. So it will be good for you to note down. Please, if it is completed, let me know. No problem. Take your own time. And once again, I'm just saying yes. I think out of I think 40 students are there. I think 40 students means yesterday class. I think by 35 students only came. Okay, can you please respond? I mean, people who did not yesterday's class. So please try to let me know those people through chat by typing me like that. Something you just type me like that, me, so that I'll try to understand who is that person who did not understand, attend yesterday's class. Please respond. Tell me, students who did not attend my yesterday's class. Everybody attended, but it's showing only 35 people. Me, very good, ma, very good, Krishna, very good. Okay, very good, ma, Reshma, Sham Krishna. See, guys, please. I said no. I think I taken only some topics from yesterday class. You please try to go through that. If you are not able to understand, so I think once again yesterday also I had given my mobile number. Once again I'll be giving my number. Please note down. You can call me and you can ask your doubts. No problem. Okay. Otherwise I may forget. I'm just giving my mobile number now only. Those who wants to note down, they can note down and they can please feel free and you can ask doubts. No problem. Okay. 7842426603 and my name I said no, Sudarshan. Because you should not feel shy in asking doubts. Okay, if you are if you are very good in interactive, then definitely you can learn the subject. Okay, right. Very good. Completed, everybody? Completed? Yeah, very good. Can I? Yeah, I'll go for next topic. Okay, please wait. Let me erase this one. Right. So guys, next one. This is about the features of transformer. Okay, features of transformer. Now, yeah. So let me discuss the types of magnetic coupling. Okay. I'm once again just saying, please get up those who are sleeping, everybody, please, because it's very topic is very important because it deals with the direction. So we have to show your hand clearly for you have to show your wrapper fingers and thumb clearly, then only you'll get a correct direction for flux, all those things. Okay, be active. Can I start? Yes, very good. Very good. Please give me, yeah, very good. Thank you for responding. Okay, please give me 10 minutes. In these 10 minutes, please let me explain this subject. Let me explain this topic. And after 10 minutes, I'll ask you if you are comfortable. If you really understood, then I'll go for next slide. Otherwise, we'll explain once again. Okay, don't worry. So see guys, I told you already in transformer, I told clearly, yes, windings are magnetically coupled with each other. Okay, see, for types of magnetic coupling means you are having two types of coupling: positive type of coupling, negative type of coupling. What is that? Positive type of coupling and a negative type of coupling. Okay, see, I'm just going to explain positive type of coupling and a negative type of coupling. Okay, but for that I'm not taking transformer here. I simply have taken a course. This white color border, whatever I just drawn rectangular portion. I taken a simple piece of magnetic material, I can say. Okay, and I just wounded two windings, blue color winding and red color winding in this figure number 1. And in this figure number 2 also blue color winding and a green color winding. Okay, and I had taken figure number 3, figure number 4 also. In figure number 3, yes, yellow color winding and a green color winding. And figure number 4, yellow color winding and what about this one? Green color winding. Okay, guys. So here you should be very comfortable with right hand thumb rule. That is very important. Okay. See, please try to understand. Please try to understand. You know, guys, suppose if a voltage source is like this, if already everybody knows that if you take a voltage source, just wait for some. If you take a voltage source, everybody knows that. So direction of current will be like this, no? If you take plus, minus, so current direction will be like this, no? Please respond for this one. After that, I'll proceed. So if you take source, direction of current will be like this only, no? Yes, very good. That means, please let me say once again, in a source, current enters at the minus terminal. Current leaves from a plus terminal. Is it clear? In a source, current enters at a minus terminal, whereas leaves from a positive terminal. So this positive one I'm taking it as I can say phase, and the negative one I'm taking it as a neutral. Okay, guys. So that means a neutral terminal current has to enter. Yes, let me show here. So current is entering at a neutral. Okay, and it is leaving from a phase. Okay. Now up to here, this current is entering here. Okay, guys. Right. Now up to here, is there any road one? Very good. Now please let me explain here. So do you have? Please try to understand here. Front and back end two ends will be there. That is very important. So tell me why I called this end is front end. Everybody, can you please respond so that it will be good to you and for me also. You can understand clearly why this end I'm calling it as front end. Whatever the answer you know, please tell me. Very good. Current enters, not like that. So it's not depending on direction of current. Please see, it's very simple. If you take this core, please try to assume everybody. Very good. Nice answer. All. Yes. If you take this magnetic core, which is in a rectangular shape, just try to hold by using left hand. Let us assume that you just hold a rectangular core by using left hand. And by right in your right hand, you are having winding is there. This blue color winding is there. So you please wound from from front side to back side. You just try to wound winding from front side to back side. That means winding is going from front end of the core and it is leaving at back end. Okay, everybody, can I ask one question to you? So can you able to see winding which is entering at front end here? This portion. Can you able to see winding which is entering at front end? Yes or no? Everybody, please respond. Can you see direction of sense of winding which is winding which is from front side of the core. Yes, everybody. Can you able to see winding which is going from back side of the core? Can you able to see winding which is going from back side of the core? I'm asking winding which is at back side of the core. You cannot see, guys. Abhijit, you cannot see, right? Yeah, very good, very good, very good. Yeah, Ruben, very good, Mambuta. Yeah, that means here you are able to see only here. Just try to understand. Here winding is going from front side of the core and it is leaving at back end. Once again, it is entering at front end. It is leaving at back end. Please try to see this laser point. Winding is going from front side of the core. It is leaving at back end. It is entering at front end, leaving at back end, 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 entering at front end. Tell me here where it is leaving. In winding at end point here with this blue color, it is leaving from back side or it is leaving from front side? It is leaving from back side. Very good, very good. Thank you, ma. Thank you, thank you, thank you for understanding. Okay, and here winding is coming like this. If you see in a B winding, once again in B winding also, winding is going from front side of the core. Yes or no? Yes, just like coil A. It is leaving from back side, entering from front side, leaving from back side, entering from front side, leaving from back side, entering from front side. Similarly like that. Let's go on and see where winding is leaving, guys. Is it at back end or front end? Back end. That means front and back end means it is not by seeing direction of current. Please let me conclude. It is not decided by seeing direction of current. Okay, it is not seen by direction of current. So it is depending on how you are winding. Suppose if winding is going from front side of the core, front side of the magnetic material, that we can get as front end. If it is leaving from back side of the core, that we can get as back end. That's it. Okay. So now let me ask question. I think you are familiar with this. Why I wrote front end here? Why I wrote back end here? Why I wrote front end here? Why I wrote back end here? Yes or no? Everybody, are you familiar with this indications? Very good. Similarly, okay, guys. Very good. Very good. Now tell me this figure. This is about figure number 1. Now please see figure number 2. In this figure number 2. Do we have any change in sense of winding? I'm asking, do we have any change in sense of winding? Sense of winding in the sense, here it is front end, no? Here also front end. Back end, here also back end. Front end, here also front end. Here back end, here also back end. Tell me, do we have a same sense of winding or different sense of winding? If you compare figure number 1, figure number 2, everybody, figure number 1 and figure number 2 having same sense of winding or different sense of winding? So somebody, so Johan, it's not, you said different, it's not correct, right? Abhijit, why you are saying different? I'm asking about a sense of winding. Please try to see. Don't see connection. Don't see connection, Abhijit. See, I said, please wait. I said here it is a front end, no? And here it is a, very good. It is front end, back end, front end, back end. In this figure number 2 also front end, back end only. That means, let me conclude. Figure number 1, figure number 2 having sense of winding. Is it clear, everybody? Figure number 1, figure number 2 having same sense of winding. Is it clear, everybody? Yes, very good. Sanju. Thank you. Thank you, Sanju. Thank you, Amrita. Thank you, Ma. Thank you, Anjana. Okay, thank you, Shyam. Now, see figure number 3, guys. In this figure number 3, guys, if you see coil A, it is front end. Everybody knows that. Just like whatever I told here, winding is going from front side of the core. That's why I'm calling it as front end. In coil number A, this end, winding is coming from back side of the core. We call it as back end. Very good. Now, please be careful here. Wherever I'm just showing cursor, everybody, I said, this cursor. Tell me this from here in coil, coil B, is it going? Is it going from back side of the core, or is it entering from front side of the core? Is it entering at back side or is it entering at front side? Back end. Very good. So it is going from back side, coming from front side, going back side, coming front side, going back side, coming front side, like this. Okay, and going back side, coming front side. This is nothing but direction of, this is nothing but winding which is coming from a front side in coil B. Okay, guys. So front end, back end, front end. Okay. And what about figure number 4? If you see figure number 3 and figure number 4 having same sense of winding, yes or no? See front end, back end, back end, front end. Same sense of winding, different sense of winding. I'm asking about figure number 3 and figure number 4. Same, very good. So guys, very good, ma, very good, Shweta, very good, Shweta. There's a reason, guys, everybody. There's a reason why I just given some flower bracket for this figure number 1 and figure number 2. I had given flower bracket for this figure number 3 and figure number 4. In middle, I wrote what? Same sense of winding. That means 1 and 2 having same sense of winding, and 3 and 4 having same sense of winding. Is it clear, everybody? Now let me start. Let me start my subject. Okay. Now tell me, guys. Please try to see figure number 1. Please try to see figure number 1 and tell me where current is entering. I told, please respond. In figure number 1, where current is, it is entering at front end, right? Yes, it is entering at front end. This is the direction of current which is entering from front side of the coil. And where it is leaving, guys? It is entering from front side of the core. It is leaving at back side, huh? Yes or no? Can you able to see direction of current which is coming downwards? Can you able to see direction of current downwards at backside? No, I cannot show. Very good, Shweta. Very good, Shweta. It is leaving from backside. Once again, it is entering at front side. So ultimately, I can show here only direction of current which is entering from front end. See, it is leaving at back end, entering at front end, 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 leaving at back end. Yes, it is coming like this, going like this. Yes, once it is entering at front end, no, entering at front end, leaving from back end. Once again, entering at front end, leaving from back end, entering at front end, entering at front end, entering at front end, entering at front end, leaving at back end. Okay, guys, everybody, are you familiar? Are you comfortable with this arrow marks? Please let me know. Yes or no? Very good. This means in coil A, direction of current from front side is this. This is the one. This arrow marks indicates in coil A direction of current which is entering from front end of the core, which you can see by front side. Okay, but you can, but downward arrow marks are there, but you cannot able to see those arrow marks, which are they are back side of your core. Don't see, don't confuse with that. Okay, you can able to see front side direction of current which is upwards here in coil A and coil B. Okay, now tell me, I told you for circular conductor, by using right hand thumb rule, in circular conductor, I told you wrapped fingers. Wrapped fingers. Let me take this figure so that you will be having some clarity, guys. Let me take this figure. Very good. Can you, okay, can I, 1 minute, 1 minute. Can you please, please try to see this, please try to see these two figures, which I just, this one, first one and second one, first one, second one. This is the first one, this second one. Now tell me, guys, everybody, you have to answer. In coil number A, so for showing direction of current, I have to use first case or second case, everybody. Now I'll try, I'll understand how much you understood, that I will come to know. Okay, I'm asking, guys, everybody, let me repeat the question. In coil number A, for showing direction of current, so I told you wrapped fingers means direction of current, thumb means direction of flux, no, in a circular conductor. So tell me in figure number 1, for showing direction of current and for having direction of flux, I had to use first one or second one now. Very good, very good. First one. Very good, first one. That means if you see first one means here wrapped fingers, this remaining 4 fingers, this is whatever this arrow mark is there. This arrow mark is the thing, but this arrow marks only. Is it clear? This arrow mark is the thing, but this arrow marks only. Okay. And tell me what the direction of flux here, right to left or left to right in coil number A. Respond, guys. I'm asking about yes, please respond. Yes, right to left. Very good, man. Right to left. So this is what I can say: flux right to left, right to left. I call it as pi A, flux in a coil A. Similarly, guys, tell me in coil B, for showing direction of current which is entering at front end, I have to use figure number 1 or figure number 2. It is entering at front end. Tell me figure number 1 or figure number 2. 1. Very good. Yeah, please, here at least one of you, please give me wrong answers so that I'll be having some. I'll be feeling very happy. You are giving right answers. Okay, very good. So figure number B, yes, it is entering at the front end means I had to use figure number 1. So by using figure number 1 second, this arrow mark indicates this yellow color arrow marks only. So 1 second direction of flux, I think, but given by thumb, it is from what, ma? It is what I can say, right to left or left to right? It is right to left. Please respond. Right to left or right to left? Very good. Right to left means like this. Right to left. So I call this flux as pi b, pi b, pi b. Okay, guys. Now tell me in this figure number 1, what about pi b and pi a? They are aiding or opposing? Please respond. In figure number 1, I said they are from pi b is aiding with your pi a or opposing with your pi a? Is it aiding or opposing? Aiding. Very good, very good. That means I can write here pi b, aiding with pi b, aiding with pi a. Okay. So therefore, which type of coupling? Positive type of coupling. Positive type of coupling here. Positive type of coupling. For positive type of coupling, these two windings are magnetic coupled through magnetic coupled. So this is what I can say. M means what? In mutual inductance. For positive type of coupling, M is nothing but positive. M is what I can say, positive. Is it clear? So for positive type of coupling, M is positive. Okay, is it clear, everybody? First one. So tell me, ultimately, first figure means you are getting positive type of coupling, no? Yes or no? If you understood first one, guys, second, third, fourth, they are very easy. You only will tell answer. Tell me now. No, I won't say anything. You have to give your answer. Okay. Please, everybody, don't sleep. So figure number 2, I said, tell me current is entering at a neutral terminal here. It is leaving from phase terminal. It is entering at front end. It is entering at front end of the core. Okay, front end of the core. It is leaving at back end. Once it is entering at front end, entering at front end, entering at front end, entering at front end, entering at front end. It is leaving at back end. Please try to understand. Here, figure number 1, back end of your coil A is connected to front end of coil B. But whereas in the figure number 2, back end is connected to back end of coil B. Front end of coil A is connected to front end of coil B. Okay, just try to see this connection. Okay. Now see, current is leaving from back end in coil A. It is going like this. Yes, going like this, like this, like this. Now tell me where current is entering. In coil B, in this position, tell me where current is entering at back end or front end? Back end. Very good. It is entering at back end, guys. That I cannot show here. You cannot see back end portion. No, it is entering at back end, whereas leaving from front end. That means tell me here direction of current will be from top to bottom or bottom to top. See, it is entering from back side, right, and it is leaving from front end. So tell me direction of current from top to bottom or bottom to top? Top to bottom. Very good. So top to bottom. Top. Once again, it is current is leaving from front end. It is entering at back end, leaving from front 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 end. It is coming. It is leaving at front end like this. Okay. So now please decide direction of flux in coil A and coil B, please. So though you know, please I'm asking once again. So in coil number A, for having direction of flux, for having direction of thumb, your rapid fingers you have to show like figure number 1 or figure number 2. Like image number 1 or image number 2. I call this one as image number 1. Okay, 1. Yeah, very good. 1 means, guys, you have to show like this. Let me use laser point. So some people are confusing. This one. So if you show like this, thumb meaning direction of flux, no? Yes, in coil A, so I can say that direction of flux will be from right to left, like this, right to left, pi A. Okay, guys. Now, what about in coil B? Please answer. In coil B, I'm asking for showing direction, for having direction of thumb. In what direction your rapid finger should be? In like figure image number 1 or image number 2? 2. Because it is entering at back end, no? That means you please try to see this figure, this figure, guys, everybody. This arrow mark is nothing but whatever I'm just using this mouse, whatever this laser push is there. This arrow mark, downward arrow mark is nothing but this yellow color only. Okay, so you have to hold this core in this manner. So flux will be given by thumb. It will be from left to right or right to left. Respond, please. Left, right. Very good. Left, right. So this, like this. Nothing but pi b, I can say pi b. Okay, guys, pi b. Now tell me, in this case, I'm asking, tell me what about pi b and pi A, they're aiding or opposing? In figure number 2, pi b and pi A, they're opposing or aiding? Opposing. So I can write here, can I write like this? Pi b opposes with pi A. So which type of coupling? Therefore, negative type of coupling, negative type of coupling, where mutual inductance M is what I can say, negative. Is it clear? Is it clear? Everybody, please respond. Is it clear? Yes. Yes. Thank you. Now, my conclusion. Let me conclude, guys. Let me conclude. So, you please tell me. Compare figure number 1 and figure number 2. This I can say. Please try to see this flower bracket. This flower bracket. Please try to see this flower bracket. So, if you see this flower bracket, tell me, guys. Figure number 1 and figure number 2 are having same sense of winding, different sense of winding. I am asking about figure number 1 and figure number 2. Same sense of winding, different sense of winding. Same, very good. Yeah, very good. Though sense of winding is same, type of coupling changed or not changed? See, in figure number 1, it is nothing but positive type of coupling. No. In figure number 2, negative type of coupling. So type of coupling changed or not? Changed. Very good. Thank you, guys. Thank you. That means if you take, if you say, if in this figure 1 and figure 2 discussion, suppose if you see this flower bracket, I think, but considering figure number 1 and figure number 2, in this discussion, please take, everybody, please take figure 1 as a reference for us. Figure 1, I'm just going to take it as reference here. See, it's a reference for us. Figure number is reference for us. Okay. So in these two figures, if I take figure 1 as reference, so for the same sense of winding, type of coupling changed or not changed? Sense of winding is same, but type of coupling changed or not changed? Changed. Okay. See, tell me, guys, how it's happening? How it is happening? If you observe in coil A, in figure number 1, it is upward direction. In figure number 2, coil A direction upwards only. And what about in coil B of figure number 1, it's upwards, whereas coil B of figure number 2 is downwards. That means, so though sense of winding is same, if direction of current is changed in one coil, type of coupling can be changed. Is it clear? Please respond. Though type of coupling is, though sense of winding is same, if you change direction of current, in this example, figure number, please try to see figure number 1, figure number 2, coil B direction of current is upwards here, coil B current direction is downwards. If you change direction of current in coil B in this example, so coupling was changed. If previously it is positive, now it is negative. Yes or no? Respond, please. Yes or no? Yes. So that only, guys, please respond. Please try to see. That only I wrote here as a point. Please, everybody. So please let me underline this. Otherwise, let me use this laser. Please try to see this note, everybody. Please try to study this note for the same sense of winding. So tell me, for explaining this point, for the same sense of winding means which figures I have taken 1 and 2 or 3 and 4? Still now I'm saying. By this time, I think we have taken 1 and 2. Yes, figure number 1 and figure number 2, if you take, so where figure number 1 and figure number 2 having same sense of winding, okay, type of coupling can be changed by changing the direction of current. So this word is very important. Let me underline this statement. So what I said simply, yes, for the same sense of winding, though sense of winding is same, type of coupling can be changed by changing direction of current. In our figure, coil B direction of current was changed. No, that's right. Okay. You please observe this note. Here we can explain the statement by using figure number 1 and figure number 2, which we did now, or figure number 3 and figure number 4 also. In the same manner, if we explain by considering figure number 3 and figure number 4, figure number 3, figure number 4 also will be having same sense of winding. Figure number 1 and figure number 2 will be having same sense of winding. But don't compare 1 and 3. Don't compare 2 and 4. I am just, please, for explaining this statement, you should take 1 and 2, or that's why I used some separate color I used here. 1 and 2 you should use, or 3 and 4 you should use. Okay. So I think I explained by considering figure number 1 and 2. Yes or no? Can I explain the same statement instead of taking figure number 1 and figure number 2? Can I proceed by taking figure number 3 and figure number 4? Can you please allow me to explain figure number 3 and figure number 4 also? Can I start? Same concept, same thing only. Instead of taking figure number 1 and figure number 2, I'm just taking figure number 3 and figure number 4. It is not for me, it is for you only, guys. You should respond. You should respond. Okay, you should respond. Tell me here, what is the direction of yes, you please respond. You know, in figure number 3, I'm explaining now. Everybody, please try to see at figure number 3. At neutral, it is entering. Phase, it is leaving. So it is entering at front end. So entering at front end, leaving at back end, entering at front 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 end, leaving at back end. Yes, leaving at, I mean, entering at front end in coil B also. Okay, and it is entering at back end, but we cannot see. But after entering at back end, it will be leaving from front end like this. And once it is entering at back end, that we cannot see. It is leaving from front end, front end, front end, front end, front end. Okay, like this. Okay, guys. So like this path is completed. Now tell me, in coil number A of your figure number 3, I have to use image number 1 or image number 2? Respond. Image number 1 or image number 2? 1, very good. 1 means if I show direction of, if I show rapid fingers in this manner, this arrow mark nothing but this one I said. So thumb indicates direction of flux. Simply I can write pi A in this manner, pi A. Okay. And what about in figure number B, guys? Figure number B for showing direction of current. Rapid finger should be in like image 1 or image 2? Image 2, very good. So we have to hold this core in this manner, like figure number 2. So at that time, direction of flux will be from left to right or right to left? Respond. Left to right or right to left? It's from left to right, no? Very good. So now, yeah, thank you. Now please tell me, in this figure number 3, what's happening here? Pi B and pi A opposing or aiding? Respond. Pi B opposes pi A. Pi B opposes pi A. Therefore, what will have which type of coupling here? Respond. Negative type of coupling. Very good. Negative type of coupling. Very good. Okay. So where M will be negative. Okay. So see, guys, before in this, if I use figure number 1 and figure number 2 for explaining, see, I'll use laser for understanding point of view. See, before in first case I use figure number 1, figure number 2. There, which one is reference for us? Figure number 1 is reference for us. Nothing but positive is reference for us. Positive is changed to negative here. Like that, in figure number 3 and figure number 4, if I use, tell me which one is reference for us. I'll take figure number 3. Can I take figure number 3 as reference in my discussion now, please? Can I take figure number 3 as reference? Yes. So let me write that, please. Let me write that. First of all, in this discussion, figure number 3 is reference for us. Nothing but negative type of coupling is reference for us. That should be changed to what? Positive. Though sense of winding is same. That only, no, we explained previously on point. Okay. But I'm explaining once again by taking this, these two figures. That's it. Okay. Can I? Is it clear? Figure number 3, everybody? Respond, please. Is it clear? Figure number 3? Yeah, very good. Now, what about figure number 4, guys? Once again, see. Thank you. See here. It is entering at a neutral point, leaving from a face. Okay. Entering from a front end. It is entering from front side like this. It is leaving from back end, entering from front side. Leaving from back end, entering at front side. Leaving from back end, entering front side. Leaving from back end, entering at the front side. Yes, leaving from back end like this. Yes. In coil B, tell me where current is entering. At front end or back end? Front end, no? Front end means this direction of current which is entering at coil B. It is leaving at back side that we cannot see. And once it is entering at front end, 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 leaving from back end, that only can show here. This like this path is completed. Okay, guys. Very simple. In figure number 3, back end is connected to back end, front end is connected to front end. Source is connected between the front end and front end of coil A and front end of coil B. In this figure number 4, back end of coil A is connected to front end of coil B. Source is connected between front end of coil A and back end of coil B. That's it. Now, please let me conclude the 4th one. So, in figure number A, guys, sorry, figure number 4, in coil A, I have to use image 1 or image 2. Respond. Everybody, 1 means this one, no? So this arrow mark, nothing but this arrow marks. And thumb means from left to right or right to left? Right to left. Pi A. And what about in coil B, guys? I have to, current is entering at front end or back end? Current is entering at front end or back end? Respond, please. Entering at front end, back end? Front end. If it is entering at front end, please tell me I have to use image 1 or image 2? Image 1, very good. Image 1. If I use image 1, guys, so flux will be from right to left or left to right? Right to left or left to right? If I use image 1, right to left. Yes, this is from right to left. This is what I can say pi b, pi b, pi b. Okay, guys. Now tell me in this case what's happening ultimately? Pi b aiding with pi b aiding with what? Pi b aiding with pi a. So which type of coupling? Therefore, positive type of coupling. Positive type of coupling. Okay. Thank you. Thank you. Thank you, Amasham. Positive type of coupling. So where m will be what I can say? Positive. Okay. So please try to see. I think we explained one note. What is that note? For the same sense of winding. So for the same sense of winding, since I'm using the word, you can use figure number 1 and figure number 2 like this. Figure number 1 and figure number 2 you can use or. I'm saying or, not under. You can use this 2 or that 2. So you can use figure number 1, figure number 2, or figure number 3 and figure number 4. So that figure number 1 and figure number 2 having same sense of winding. Figure number 3 and figure number 4 having same sense of winding. Though sense of winding is same, type of coupling can be changed by changing the direction of current. See guys, in this discussion in figure number 3 to figure number 4. So previously it is a negative, no? Reference is negative type of coupling, which is changed to what? Positive. Yes, change type of coupling was changed. You please try to see this arrow marks, direction of current in coil A upwards. Here coil A also upwards. In coil B of your figure number 3 downwards. In coil B of your figure number 4 is what? Upwards, no? Yes, this one is changed, no? That means direction of current in coil B is changed. Though sense of winding is same, type of coupling is changed. That's it. So please let me conclude, guys. Only 2 points I want to focus here. What are those 2 points? So I think this point. See, if sense of winding is same, type of coupling can be changed by changing direction of current. That is very important. Okay. So this is very important point. And one more point I need to focus. That will be very useful for us for coming sessions. Okay. Every time, everybody, just try to understand. Whenever current is entering at front end, you please try to see this image. First image. Everybody, first image. Are you able to see first image? Cursor, please. Everybody, please respond. Yes, like that. Yes. Yeah. Everybody. This point is very, very important. Very, very important, ma. This point. Whenever current is entering at the front end of core, you have to hold that core like image 1. That you have to remember. It's very, very important. Okay. Whenever it's entering at the front end, you have to hold core in this manner. Okay, guys. If a core is horizontal, here we are holding like this. If it is vertical, you can hold in you can hold once again in the same manner. But thumb will come what? Okay, I'll ask one question. If current is entering at front end, if core is horizontal, you're getting direction of flux means right to left, no? Very good. Suppose if core is a vertical shape, once again current is entering at front end. At that time, what is the direction of thumb? Will be upwards or downwards? Sham, wrong, please. It's not upwards. See, don't confuse. For your making you understand, I'll do one thing. See, yeah, this one I'm saying. See, here it is. Like, what about the same front end or back end? I respond. This one front end, back end. Front end. That means front end means I told you to hold core. Like image number 1, that means your rapid finger should be on the core. It's not under the core. Okay, on the core. If you hold a core, and if you are holding a core, that's such that your rapid finger should be above the core, your flux will be direction of flux will be upwards or downwards. Sir, respond please. Up or down? Direction of flux. Vishnu, wrong. You are saying not down. Wrong, down. Vishnu, is it clear? Please, everybody. Some people are giving guidance, okay? But Vishnu, please, I'll explain once again, please. Okay, clear, sir. Okay, very good. Thank you. That means you have to hold a core such that your fingers, remaining four rapid fingers should be on the core. Okay, that thumb will be upwards. Okay, is it clear, everybody? Please respond yes or yes like that. Suppose if current is entering at back end, you have to hold your core like image number 2. Suppose here core is horizontal, you are holding core like this, your flux is coming from left to right. Suppose I'm asking question once again, I'm asking question. If core is vertical, if core is vertical, if you hold, if current is entering at back end, if you hold core in this manner, direction of flux, down or up? Down or up? Please respond. Down. Thank you guys. So these very simple points only. These 2 points only I want. Remaining all those things are not necessary for us. But you should know, you should be very familiar with sense of winding also. That's why I have taken this topic. Okay, guys. So I'll give some time. So please note down these notes. And here, see, I told already here. This note, I think I explained it. If you see this note, what I said, ma, if 2 fluxes are aiding with each other, it is a positive type of coupling. It is, everybody knows that. If 2 fluxes are opposing with each other, it is negative type of coupling. Okay. But can you please tell me, guys? I am saying definition for a positive type of coupling and definition for negative type of coupling in this manner regarding flux point of view. But can you please tell me? Can you able to see flux? Respond. Can you able to see flux? I'm expecting answer from you. Can you see flux? I'm asking. No. Very good, Bharat. Very good, Bharat. So, but what is it? I mean, I had given one definition. No, what is the definition I had given? If 2 flux are aiding, I call it as positive of coupling. If 2 flux are opposing, I call it as negative of coupling. Then I'm asking question: if you are not able to see flux, and then how can you decide the direct? How can you decide type of coupling? Can you please? If you are not able to see direction of, if you are not able to see flux, how can you decide type of coupling? Very simple, by using dot notation. What is that? By using dot notation. That only I had given clearly here. Okay, but flux is invisible quantity. So for deciding type of coupling, dot notation is used. Okay, guys. So please, I'll give time. Note down this slide. If it is completed, please let me know. If you think that it will take more time, you can. Is it possible to take screenshot? Is it possible to take screenshot? Respond, guys. Is it possible to take screenshot? Because it will take a lot of time, no, for you to draw. Yes. Yeah, very good. You please take screenshot. Afterwards, you can after completion of class, you can draw. No. Is it okay for you? Is it okay after taking after taking screenshot? Okay, right. Very good. Now, please let me go to. If you are everybody are comfortable, then only I can proceed. Otherwise, I cannot. Okay. Some people are responding yes like that. Okay, I can proceed. Okay. Right. Dot notation. Okay. See, guys. Your point is here. One thing you have to understand. Yeah. So why dot notation is used? So very simple thing. I told if 2 flux are aiding, it is positive of coupling. If 2 flux are opposing, it is negative of coupling. But flux is invisible quantity. We cannot see the flux. But deciding type of coupling only, we are going for dot notation. Then you may get one doubt, sir. Where do I have to assume dots, sir? Is it a question? Can you please tell me where you have to assume dots? Tell me in this figure number 1. Tell me where you can assume dot. Answer from you guys. Answer from you. I'm expecting answer from you guys. Where we can assume dots? Front end, front end, Bharat. Okay, very good. Front end means you mean to say that front end of coil A and coil B, or front end at coil A and back end at coil B? Both coils. You mean to keep dotted front end, Bharat? Both front end. In coil A, front end. In coil B, front end. You want to keep dot. Yes? A very good object. Very good object. Very good. Is there any different answers? Any different answers? Where we can assume dots? At front end of the coils or back end of the coils? Or it's our own? It's our wish. Is it our wish? Is it our wish? Very simple thing, guys. Please try to understand. So many people are giving answer front end like that. It is not back end, Amruta. Back end, Amruta, you said, right? See, your answers are our wish. Very good, Sanju. Exact. Very good. Chandran, Sanju Chandran. That is very good. Nice answer. It's our wish. Let me repeat once again. It's our wish. We can assume dots at front end of coil A and front end of coil B, or at back end of coil A and back end of coil B. It's our wish. But one thing you should remember, if you assume dot at front end of coil A, you should assume dot at a front end only at coil B. Suppose in coil A, if you assume dot at back end, in coil B, you can assume dot at back end. Okay, guys, let us assume that in our discussion, I am assuming dots at the beginning end of a coil. So please here, let me repeat once again. Assume dots at the beginning end or ending end of a coil. It's our wish. But my question is, which one is beginning end, which one is ending end? Please let me ask question once again, please. I think one person is there. He is. I mean, I don't know what is the reason why he's going left and coming once again back. So please try to be in the class continuously so that you can understand. Otherwise, you'll be having some confusion. Please don't go anybody. If there is any technical problem, that is okay. Otherwise, please have patience. Huh? So I'm asking a question. Assume dots at the beginning end of coils or ending end of coils is our wish. But don't tell me which one is beginning end, which one is ending end of this coil A and coil B. See, I had given front end, back end, front end, back end. I had given in terms of front end, back end like that. Okay. I am asking now in terms of beginning end and ending end. So tell me in coil A, which one is beginning end, which one is the ending end? In coil A, which one is beginning end, which one is ending end? Tell me, I'm expecting answer from you guys. Front end is beginning, Abjit. Okay. Any different answers? Current entering terminal. Very good, Bharat. Next, any different answers? Okay. Suppose Bharat, let us take your point first of all. You are saying that wherever current is entering, we call it as beginning end. Is it correct? Is it this what you want to say? Bharat, wherever current is entering, you mean to say that, okay, you mean to say that is beginning end, right? Yes. But I'll prove that it is not correct. Okay, please wait. See, suppose you mean to say that wherever current is entering, that you are writing it as beginning, right? So that means here current is entering. In your point of view, it is beginning end, no? Yes or no? Everybody, please respond. Regarding Bharat, if current is entering at if wherever current is entering, you call it as beginning end, right? So here it is entering. I call it as beginning. Okay, and here it is leaving. So can I call it as ending end? Ending end, yes or no? Ending end. So you can call it as ending end. Okay, ending end. Next, what about in this coil B? Front end, no, sorry, don't see front end, back end. I'm asking, here current is entering, no, in your point of view, it is nothing but beginning end. It is leaving, no, it is nothing but ending end. Is it clear, guys? Okay, so if I take Bharat point or Abjit point, they said that wherever current is entering, that we are calling it as beginning end. Wherever current is leaving, they are calling it as ending end. But it is not exactly correct. Why means I'll show you. See, by this seeing the direction of current, if it is entering, we are calling it as beginning end. If it is leaving, we are calling it as ending end. So this, see, if you assume like this, now tell me ultimately, indirectly, what you are taking here, front end is taken as beginning end in this discussion. Back end is taken as ending end in this discussion. Front end is taken as beginning end in this discussion. Back end is taken as ending end in this discussion. Is it clear? Yes or no? So by seeing direction of current, you are deciding beginning and ending end. Ultimately, what is the conclusion you are getting here? In this example, indirectly you are taking front end as beginning end, back end as ending end. Front end as beginning end, back end as ending end, right? This should not be violated. This should not be violated. So please try to see figure number two. Please tell me figure number 2 regarding your point of view. You said it is whenever current is entering, you call it as beginning end. Yes, I call it as beginning end. Leaving, ending end. In your point of view, ending end. Okay, here it is entering. No, entering means regarding your point of view, what you should write here? Beginning end. But here condition is violated. Yes or no? Respond. Yes or no? Yes, because here if you observe clearly, guys, everybody, here back end means you are taking it as ending end, but here back end becoming a beginning end. That is not correct. Okay, so please be careful. Beginning end comma ending end is decided by sense of winding, not by direction of current. What is that? Is decided by sense of winding. How you are winding. Suppose you are example. See in this case, figure number 1. If you take a, you are starting winding like this. You are starting winding like this. Some person is there here. Let me show that person also. Let us assume that some Bharat is there here. Okay. Okay, Bharat is there. So here he is seeing this coil A, and he started winding this coil. Started winding this coil from this side. So this is starting point of this person. So in this case, this front end is becoming back end. So it is winding is like going like this, winding is like this, it is like this, and it's coming at back end. No, that means if he is starting at this point, front end can be taken as beginning end, back end can be taken as ending end. Is it clear? Some people will think like this. Suppose, see, some people they'll want like this. See, he'll start from here. Suppose if you take, excuse me, please try to see. If you see figure coil number A, if Abhijit is here, or if Bharat is here, if he's starting winding like this becomes beginning end for this person, and this becomes back end, ending end of this person. Suppose one more person is there, who is standing here. Who is standing here? See, let us see. He is standing here. He started winding from here. He started winding. He started winding from here. So he started like this. So now for this person, this becomes beginning end, and he is completing. He's completing like this. Is it clear, guys? So can you able to understand what I am saying? Please respond. Yes or no? Very good, Abhijit. That means regarding this person, front end is becoming beginning end, back end is becoming ending end. Regarding this person, back end is becoming beginning end, front end is becoming ending end. Is it clear, everybody? This point? Respond. Yes, that means it is not beginning end comma ending end is not decided by direction of current. It is simply by sense of winding. So you can take front end as beginning end, or you can take back end as ending end, or you can take back end as beginning end. Front end can be taken as ending end. It's your wish. It's your wish. But in my discussion, I am taking front end as beginning end, back end as ending end. Okay, guys, that only I wrote here. Please let me show you so that you'll be having some clarity. See, now please try to study this point. Assume dots at beginning end of coils or at ending end of coils. It's our wish. But beginning end comma ending end of coil, beginning end end of coil or ending end of coil is decided by what? Sense of winding, not by direction of current. This point is very important. Let me underline this point with some different color. So decided by what I said, sense of winding, not by direction of current. Very good. What I said in our discussion, we assumed, so please try to see this point also. We assumed front end as beginning end in this discussion, back end as ending end in my discussion. It's not compulsory. You can take reverse also, guys. You can suppose instead of taking a front end as beginning end, you can take back end as beginning end, and you can take front end as ending end. It's your wish. But anyone you have to follow. Okay. So in my discussion, I assume front end as beginning end, back end as ending end. In our discussion, I told you already, we can assume dots at beginning end of coils or ending end of coils. Your wish. In our discussion, we assume dots at the beginning end of coils. Please try to study these 2 points, and I'm just going to ask some questions. Everybody, this note. In our discussion, we assumed front end as beginning end, back end as ending end. So in our discussion, we assumed dots at the beginning end of the coils. So now please try to keep dots here. Tell me, everybody. So I think front end, wherever it is there, simply you should replace with the beginning end, front end, beginning end, back end, ending end, front end, beginning end, back end, ending end. Like that, I complete all those things. Okay. So let me proceed. Tell me. You should tell here what I should write. In figure number 2, at coil B at this end, is it beginning or ending end? In our discussion, respond. Very good, ma. Beginning end. Okay, I can write beginning end. Can I take some different color? Okay, no problem. Beginning end. What about this end? This end. Respond, please. Ending end. Very good, ma. Very good. Ending end. Similarly, tell me, guys. Please try to be very active for few minutes only, because it is theory 1. You'll be having some more, no doubt I can understand that, but you have to understand this topic also. Now please tell me, in figure number 3, coil A this end, which one? Beginning end or ending end? Respond, everybody. Front end. I told now in our discussion, front end is taken as beginning end. Beginning end. Very good. beginning end. What about back end? Ending end. Okay. And back end, this one please tell me everybody. Coil B back end. What I should write? Ending end, back beginning end. Very good. Ending end. Very good. Ending end. And what about coil B front end? As I told you, beginning end, right? Beginning end. And now what about similarly here also, guys? Front end is there. So write beginning end here. Back end is there. Ending end. Back end is there. Ending end. Okay. Front end is there. Beginning end. And what I think one more thing I told. In my discussion, tell me where I assume dots. Respond. Where we assume dots. I'm expecting an answer from you guys. Where we assume dots, beginning end. So simply in all those four figures, wherever beginning word is there, just keep dot there. Yes, keep dot here. Here in this coil A, this one no. Sorry, in this coil A, this is what beginning end. So let me keep dot here. Okay. And what about in? Let me use yes. Okay, sorry. In coil B, what about beginning end? Can I keep dot here? Yes or no? Please tell me. No problem. Can I keep dot here? Yes, right. Now, is it visible to you? Is dot is visible to you? Is dot is visible to you? Please, everybody. Yes. So let me use different color, yellow color. Dot at beginning end. Dot at beginning end. I think I'm not able to place dot. I think by using this cursor we cannot keep dot. Okay, right. No problem. Okay, not really. In this figure number 2, guys, beginning end dot. Okay. Oh shit. In figure number 2 only, in coil B, beginning end is here. So let me keep dot here. I'm simply placing dots wherever beginning end is. That's it. It's not technical. It's a very simple thing. In figure number 3, where this is nothing but beginning end, let me keep dot here. In figure number 3 only, in coil B, it is beginning end. Let me keep dot here. In figure number 4, beginning end is here. Let me keep dot here. Wait, in figure number 4, coil B, this is what beginning end. Let me keep dot here. Okay. Is it clear, everybody? Please respond. Do you understand why how I kept dots here? Yes, yes, very good observation, very good observation. Now we will get one definition for positive type of coupling in terms of currents. Now please let us see coil, figure number 1. Now you can understand. Figure number 1, please try to see. So in coil A, current is entering a dot or leaving a dot? Respond. In coil A, current is entering a dot or leaving a dot? Entry, very good. And in coil B, current is entering a dot or leaving a dot? I'm asking coil B, current is entering a dot or leaving dot? Entering, very good. That means if current enters in the dot in both the coils, in coil A it is entering a dot, in coil B also it is entering a dot. That means if current enters the dot in both the coils, or if current leaves the dot from both the coils. Are you understand what I'm saying? If current enters the dot in both the coils or current leaves the dot in both the coils, that can be called as which type of coupling? Positive type of coupling. In this example, figure number 1, and I think figure number 4 also. Can I take figure number 4, please? Respond. Can I take figure number 4? Can I call? Yes. Why? See, in figure number 4, tell me in coil A, current is entering a dot. Current is leaving dot, entering dot. Try to see. Current is entering data, leaving data, entering. And coil B, current is entering data, leaving data. Coil B, current is entering or leaving, entering. That means if you see in coil number, so figure number 1 and figure number 4, in both these figures, current is entering at the dot in both the coils. In this example, suppose if current leaves the dot in both the coils also, it is a positive type of coupling only. Okay, guys. Now, what about figure number 2? Please tell me in coil number A of figure number 2, current is entering data, leaving data. In coil A, current is entering or leaving? Entering. In coil B, current is leaving or entering at a dot. In coil B, current is entering or leaving at a dot. I'm asking leaving. That means, guys, if current enters the dot in one coil, whereas current leaves the dot in another coil, that is negative type of coupling. You can use figure number 2 or figure number 3 also. You can see figure number 3. In figure number 3, in coil A, it is entering a dot, and in coil B, it is leaving dot. This arrow mark. It is leaving. This arrow mark downwards. This is downwards. Okay. It is entering at this dot, whereas it is leaving from the dot. So which type of coupling? Negative type of coupling. This only I had given as here definition. Positive type of coupling means if current enters the dot in both the coils or leaves from the dot in both the coils, then it is positive type of coupling. Okay. And negative type of coupling means if current enters the dot in one coil, leaves from the dot in another coil, then it is negative type of coupling. Okay, guys. So this is about types of magnetic coupling. Is it clear, everybody? Is it clear? If it is clear, I'll ask 2 questions. I'll ask only 2 questions. After that, if you want, I'll give time or I'll go for next topic. Okay, let me ask 2 questions only. Let me ask only 2 questions. Can I ask 2 questions? Can I ask 2 questions? Yes. First question. First question, please listen carefully. First question. Tell me, guys, if I take same sense of winding, how can you change type of coupling? I'm asking. For the same sense of winding, how can you change type of coupling? Please answer that question. So for the same sense of winding, how can you change type of coupling? Change the direction of current. Yes, see this underlined, whatever I just underlined here, this is the one. Okay, so this is the first point. And second note, let me ask. So everybody, like second question, let me ask. Tell me, beginning end of a coil or ending end of a coil is decided by what? Is it by direction of current or by sense of winding? Is it by sense of winding or direction of current? Sense of winding. Very good, ma. Very good, ma. Thank you very much. These 2 points only you have to understand. That's it. Okay. And tell me, I told you already, you can assume dots at the beginning end or ending end, your wish. Okay. In my discussion, wherever front end is there, simply I kept a beginning end. Wherever back end is there, simply I kept a ending end. If you want, you can take reverse also, nothing wrong. But anyone you have to follow. That's it. Okay. Okay, guys. Is it clear? Okay. Is it clear, everybody? Please respond. Yes. So can you so you want, I think already I had given, I think you already taken a screenshot for this one. You please take another screenshot because this is the screen after placing darts. Okay, just take screenshot after placing darts. Completed. Very good, Abhijit. Now what about this slide also? Let me know if it is complete. I'll go for next topic, Lenz's law. Please, if it is complete, I'll go for next topic. Let me know. After completion of noting down, let me know. In the meanwhile, those who are having doubts, they can ask doubts. Guys, don't feel to hesitate doubts. Please ask. Because by including all those things, we are going to solve some previous questions. Okay. So while solving questions, you should not be having any doubts. So if you are having doubts, now only please try to ask. Completed, Malavika. Thank you, Amma. Thank you. Completed. Thank you, Nitin, Abhijit. Thank you. Nikhil, thank you. Thank you. Maybe it is somewhat theory. Might be you felt bored, but there is no chance for us. You cannot escape from this one because being a electrical student, that too being we are studying electrical machine subject, you should know difference between sense of winding, and you should know beginning end, ending end, and you should know front end, back end, all those things you should know. Because if you see, don't bother that, sir. We spend a lot of time for explaining this topic. No problem. Because if you understand this topic clearly, it will be very useful for us in coming sessions. Those sessions will be very fast. Okay. So, yeah. Can I go for next slide, please? Can I go for next slide, everybody? Yes. So Lenz's law. Let me discuss about Lenz's law here. Let me discuss about Lenz's law. Now I'll come to know, everybody. Now I'll come to know how many of you listened class correctly. Last video, last session, whatever types of magnetic coupling, that I'll take here as reference. Okay, if you really understood the previous topic, then you should tell answer to this questions which I'm just going to ask. Okay, guys. Okay, first question, everybody. First question. Let me ask. Can I ask question? Please, everybody respond. Yes. Very good. Tell me, guys. Okay, very good, very good. It is a source, right? Is a transformer, rectangular core transformer had taken, having primary winding, this yellow color winding, nothing but primary winding, which is connected to the source. This green color, nothing but secondary winding, which is connected to the load. Is it clear? Now, tell me, so it's a time varying voltage source. You tell me at a neutral point, current enters or leaves? Respond. Though these questions are very simple questions, but these are very important for me. That's why I'm asking. Please respond. At a neutral point, it is entering or leaving here? Entering. Very good. Entering. Let me show entering. Okay. Very good. And from phase, it is leaving or entering? Phase, it is leaving or entering? From phase, it is leaving, no? Leaving. Very good. Now, for your understanding point of view, no doubt transformer will be operated on AC supply where I have to use phase and neutral. See, phase, this is about phase and this is about neutral only, no? I just use phase and neutral only, okay? But for your understanding point of view, let me take a phase as plus. For your understanding point of view, let me take phase as plus. For understanding point of view, let me take a neutral as a minus. Is it comfortable, everybody? Are you comfortable? I have taken simply phase as positive, neutral as negative. That's it. Okay, guys. Very good one. Very good. Okay. Now, before showing direction of current, okay, very good one. Tell me, after connecting voltage source to the primary winding of transformer, you tell me transformer will take one particular current to magnetize the transformer core. What is that current? I think it is not possible to type, no? Can you please tell me what is the current taken with the transformer to magnetize the transformer core or to produce a I mu? I Abjit, Shyam. Mu means you are saying MYU, MEW. Okay, there is no chance. We cannot escape, no? Yes, thank you. Thank you for your creative thinking. Mu means MU, just like cat sound, meow, mew. Okay. Right. Yes, please tell me. Transformer will take some current. What is that current? Magnetic current. So that current only we call it as the what? I mu. Okay, I mu. Yes. Excuse me. Yeah. I mu. Yes, I mu. Okay. Current is direction of current is like this. So before proceeding to further, please decide in this discussion which one is. What about this end? This yellow color winding. This end is what I'm saying. This end I'm asking. Please, is it front end or back end? Everybody, is it front end or back end? Very good, Shweta. Very good, ma. Very good, Abjit. Very good, Malavika. Very good, ma. Very good. Jishna, very good. Ramesh, okay. Sada. I can say is it about a front end, right? Yes, it is a front end. Whatever you will write, this topic you should be explained by you only, not by me. You should tell, and I will write simply. Okay. This is front end. What about this end? This end I'm asking. Please respond, guys. What about this end? Back end. Very good. Back end. Very good back end. Now, guys, in green color winding. Wow, very good, ma. Very good, Krishnan. What about this end? This end is front end or back end? This end. Winding is going from front side of the core. It is going from back side of the core. Here. Front end. Very good, ma. Very good. Front end. And what about this end? Back end only. Back end. Okay. Very good, ma. Very good. And tell me, guys, in our previous discussion I told, we can assume dots at a beginning end or ending end, your wish. Okay. Let me write in terms of beginning and ending end also, yes, so that you will be having some revision, like you will feel something like revision like that. Okay. Whatever the previous topic is there, that you feel that it is going to revise it here. Okay. Tell me, in our discussion, wherever front end is there, that I wrote it as what? Which end? Beginning end or ending end? In our discussion. Wherever front end is there, that I wrote it as beginning end. Very good, Abhijit. Beginning end. Wherever front end is there, simply you should write it as beginning end. Here back end is there, ending end. Back end is there here, ending end. Okay. And tell me where we know discussion, where we assume dots. Where we assume dots. Respond. Beginning. It's not compulsory the beginning only. I just made like that. Okay. It's up to you. You can take a different one also. Nothing wrong. Okay. In our discussion, we assume dots at beginning end. Is it clear? Very good. Is beginning end? No. Can I keep dot here? Yes. Can I keep dot here? Yes. Okay. Here some problem is there for while keeping dot here. Cursor problem. Okay, right, no problem. Dot. And what about this one beginning and no? Can I keep dot here? Yes, yes, dot. Very good. Is it clear? Okay. Now tell me direction of in this yellow color. If in primary side, I mu current is entering at front end or back end? I mu current is entering at front end or back end? Please respond. I mu current is entering at front end or back end? Front end. So I am just going to give a direction of current. Okay, you please tell me, is it correct or wrong? Okay, is it correct or wrong? Okay, please. So IMU is entering at front side of the core like this. This arrow mark should be like this, and it is leaving from back side that we cannot see. One side is entering at front side. It is leaving at back side. Entering at front side. Okay, leaving at back side. Entering at front side. Leaving at back side. Entering at front side. Leaving at back side. Entering at the front side. Sorry, entering at it is entering at the front side, leaving at the back side. Once again, entering at the front side, leaving at the back side like this. Is it correct or wrong? Everybody, please respond. Is it correct or wrong? Direction of current. Current, no? Yes, very good. So guys, now please apply right hand thumb rule, which I explained. I think you remember, no, image 1, image 2. Okay. I think in this case, you have to use image number 1 or image number 2. Image number 1 or image number 2. 1. Very good, very good. Suppose if I hold a core like image number 1, so tell me what might be the direction of flux? Upwards, downwards? What might be the direction of flux? I'm asking upwards, downwards? Up, up, up. Very good, Shanila. Shanila, very good. Upwards. See, upwards means like this. Please, 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 everybody, everybody on the board. Yes, 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 yes. It's coming like this. Okay. Upwards. Flux is going like this. Flux is going like this. Okay. Upward means like this. This arrow should be like this. Upward. This arrow should be like this. This direction of core flux pi. And here it is downwards. 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 Okay. Okay, guys. Is it clear, everybody? Everybody, is it clear? Is it comfortable up to this? Please respond. Yes, okay, very good. Now, I'll ask a question, guys. Please tell me. Whenever V1 is the voltage here, I'll write here. So, whenever V1 is the voltage source, it's the time variant voltage source connected to the primary winding transformer. Because of this V1, you'll get some current I mu, no? Because of this I mu, you'll get some flux pi. Already you know, whenever current is flowing, flux will come. So tell me, if V1 is time variant, what about I mu also? Time variant. What about flux also? Time variant. Yes. Whenever this time variant flux linking with your primary winding of transformer, EMF will be induced. Yes or no? Respond. EMF will be induced, not induced. Everybody, induced. I call that EMF as E1. Call that EMF as E1. Okay. It's also once again time variant. AC EMF, I can call it as time variant voltage. Okay, is it clear up to this, everybody? Is it clear up to this? Respond, please. Yes. Now let me ask one question. Yeah, let me ask one question, guys. Whenever E1 is induced here close already closure path is there. So can you please tell me, because of this E1, do you get current? Yes or no? Once again, since there is closure path, in this side, some EMF is induced. Okay, I'll do one thing. Let me show that EMF first of all. After that, I'll tell you. Okay, let me show that EMF. Let me show that EMF here. Yes, this is what I can say EMF induced here. Across this primary winding, EMF E1 is induced. That is simply I just show like this. Okay. Is it clear? This E1? Okay. Because of this E1, tell me, do you get, I mean, you will get current or not? Because there is closed path, no, always just remember guys, subject, very good. Remember always electrical machine subject means current, flux, EMF, one second current, if there is closed path. That is a sequence, right? Whenever IM is there, flux is coming. Because of that flux, so E1 is induced, and if there is closed path, 1 second flux will come. Yes or no, everybody? Sorry, because of this EMF, we'll get some current. Yes or no? Yes. So I'll call that the current which is induced because of E1, I call that current as something, just let me use different color. I'll call that current as something like IX. IX is the current which I got due to this E1. Okay. And because of this IX, do you get flux once again? Yes or no? Tell me guys. Do you get flux or not? Because of this IX flowing in primary side, will you get flux pi x? Yes or no? Yes. So that flux only you are calling it as pi x. Okay. Now please try to see the statement which I wrote on the screen. Lenz law means what? You tell me guys, first of all, why we are using Lenz law? In transformer, I told you what is the type of EMF induced? Static EMF, no? Yes. If you want to know the direction of static EMF, okay, if you want to know the direction of static EMF, or I can say, if you want to know the polarities of static EMF, so we have to use Lenz law. You see here, V1 is the voltage source connected to the transformer. Because of the IMU is the current taken to the transformer. Because of flux is produced in transformer core. Because of this flux, EMF E1 is induced in transformer core. But here I cannot, I did not show here plus and minus. Do you able to see plus and minus in across E1, across this primary winding? Meaning, can you please tell me? Are you able to see plus and minus across this E1? Are you able to see across this E1? Am I across this E1 plus minus? No. Don't see this plus and minus. I'm saying. I'm asking about. Please wait. Very good. See, because of this flux, EMF E1 is induced here, and direction of this E1 or direction of current IX which is induced because of this E1 is given by Lenz law. That's it. Is it clear? Are you getting what I'm saying? So, because of flux, you are getting some EMF, right? Because of this EMF, we are getting some current IX. So, direction of this E1 or direction of this IX is given by Lenz law. That only I wrote here. Everybody, please try to see clearly. Time varying flux. Yes, this is the time varying flux. No. Are you able to see on the screen? Please respond. I'm explaining the statement clearly. Time varying flux. Yes, time varying flux. Linking a coil. Induce an EMF in the coil. That EMF one I call it as E1 here. Okay. When this coil circuit is closed, tell me here, coil circuit is closed or not closed? Closed. Is closed. A current begins to flow. Which current? IX. A current begins to flow IX in the coil. The direction of this induced current means IX or induced EMF means E1 is given by Lenz law. So tell me guys, so according to Lenz law in primary side, you can able to tell the direction of this E1 or you can tell the direction of IX which is induced due to E1. Is it clear everybody? Yes or no? Yes. Now tell me how. How means very simple. According to this law, the induced current develops a flux. Tell me the induced current IX, because of this IX, are you getting flux or not? Please respond. According to this law, the induced current develops a flux. Yes. What is the flux of pi x? No? Yes, flux. Which always opposes the change responsible for inducing this current. So this pi x is going to oppose one person. Who is that person? So that person is responsible for getting this IX. Tell me who is the person responsible for getting this IX? E1. Who is the person responsible for getting this E1 flux pi? Ultimately, in this discussion, I can take pi as cos, and you can take pi x as a effect. See, very simple. So this is nothing but I can say cos, and I can say this is nothing but what here? Effect. Okay, guys. So according to Lenz's law, so it opposes effect opposes cos. No, you can write here effect opposes cos. Effect opposes cos. Is it clear up to this, everybody? Respond, please. Respond, please. Yes. Now tell me, opposes means, tell me guys, direction of pi and pi x should be same opposite. Direction of this pi and pi x should be same opposite. Opposite. Very good. Very good. Very good, Shweta. Very good, Shyam. Very good, Amruta Krishna. Very good, ma. Very good. Opposite, no? So now please let me take, let me show direction of pi x, which is opposite to this pi. See, I think this, I mean, white color, which is upward arrow mark is there. This is nothing but flux, no? Pi. So direction of pi x should be downwards. If it is upwards, it should be downwards, no? Downwards. Yes. If it is here also, it is opposing your pi. So let me complete this path. Yes. Is it clear, everybody? Respond, please. Is it clear, everybody? Respond, please. Yes. Okay. Now, so I think some people will be having a doubt. Sir, you already shown pi x. Then actually pi x is induced because pi x is produced because pi x only, no. To be frank, first of all, ix will come, then only pi x will come. Then tell me why I just showed pi x initially for making you to understand. Because here pi x opposing pi, no. That's why I already know direction of this white color flux. So simply I just opposite to this white color flux direction, I simply drawn direction of this blue color flux opposite. Okay. Now tell me, direction of this blue color flux is downwards, upwards? Everybody respond. Direction of blue color flux downwards, upwards? Downwards, upwards, downwards. Very good. Suppose use right hand thumb rule. Everybody use right hand thumb rule. And point thumb in the direction of this blue color. And point your thumb in the direction of this blue color flux. Now tell me where current will be entering, where current might have entered, at front end or back end. Image 1 or image 2? Respond. You have to use image 1 or image 2? You have to use image 1 or image 2? Sweta, very good ma. Yes, very good. I mean, you have to use image number 2, where thumb direction is downwards. Yes or no? Thumb is downwards, and you have to hold a core from a back side of your core. You have to hold core such that your fingers should be at the back side of your core. Okay. So now tell me, current is entering at back end or front end? By using image number 2, tell me guys, if I want direction of flux downwards, tell me where current might have entered, back end or front end? Back end. Malvika, thank you, ma. Okay. So back end means, see, is it back end? I can say this is the back end. It is entering here. So it is entering at back end and leaving from front end. Entering at back end, leaving from front end. Entering at back end, leaving from front end. Entering at back end, leaving from front end. Leaving from front end, leaving from front end, leaving from front end, leaving from front end, like this. Tell me, what about this current? I call this current as what, ma? Ix. Is it clear? Ix. So this this blue color nothing but Ix only. Okay. Is it understand, everybody? Respond, please. Is it clear, everybody? Very good, ma. Very good. So guys, one thing I want to ask one question, a simple question I'm asking. So everybody, this entire, if you want me to show this entire winding, primary winding as a source, what is the source voltage? Please everybody respond. If I want to show this entire primary winding as source, tell me what might be the source voltage value. Even no? Yes or no? Respond, please. Let me show this entire primary winding as source. So at that time, what about this so source voltage becomes a E1, right? E1, very good. That means this winding only. I'm just going to draw. I'm just going to indicate as source for you. Okay, I'm just going to indicate as a source for you. Please let me show. And guys, you need to answer for my question now. This total winding, I am just showing as in the form of source. So for understanding, let me take this one as a source here. In place of winding, assume that your core is there. Okay, sorry. In place of winding, assume the source is there. Okay. So what is the source voltage? E1. So tell me, I need to place plus at bottom or top. This is the question I want to ask. Tell me. I'm asking question. So tell me, if I show this primary winding as source here, having voltage E1, tell me where the current is entering at this end. It is, see, if you take the source, current is entering from bottom, it is entering from top. Please respond. Please respond. Very simple, guys. Do very good, Vishnu. See, very simple thing. I'm asking. Don't confuse. See, it is you. At least those who are not able to understand, please try to see this laser arrow mark. Okay, it is entering this blue. I'm asking about blue color arrow mark. I'm asking about blue color arrow mark. It is entering at back end, leaving at front end. Entering at back end, leaving at front end. Entering at back end, leaving at front end. Leaving at back end, entering 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 at front end. So tell me direction of current from from bottom top or top to bottom here. Direction of current from bottom top or top to bottom. Please. Very good, Shweta. So bottom to top means, yes, let me show here. Bottom to top means, now tell me what might be this terminal. Tell me what about this top terminal? Plus or minus? Plus. Very good, guys. Very good. Plus. Very good. Plus. And what about the down terminal? Minus. What about this voltage? E1. Okay. So please let me draw separately here for understanding point of view. Yes, it is a V1. IMU direction is like this. Okay. And I wrote it as phase. I wrote it as neutral. Nothing but plus and minus. What about this one? This portion I can say. Plus, minus. I can see even value, right? Even value. And what about direction of this? This arrow mark means what, guys? If you are having confusion, I'll do one thing. Let me use the same color so that you'll be having some clarity. This arrow marks in the direction of your Ix only, right? Ix. So here tell me direction of Ix will be, it is entering at the bottom, Ix, it entering at a minus, leaving at plus. Okay, plus, minus. Is it clear, everybody, up to this? Please respond. Is it clear up to this, everybody? Shweta, thank you, ma. Abhijit, thank you. Ruben, thank you. Bharat, thank you. Malavika, thank you. Understood, everybody? Very good. Now tell me. That's it. This is very simple. If you understood up to this, then I can remaining things will be remaining portion will be very easy for you. Okay. Now tell me, in primary side, what is the relation you are going to write between V1 and E1? I'm asking between V1 and E1. Tell me relation. I'm asking V1 bar. I'm just going to write one thing. Tell me, is it correct or not? V1 bar equals to E1 bar. Is it correct? Can I write V1 bar equals E1 bar? Yes or no? No. Very good, Vishnu. Very good, Sanju. Very good, Sanju. No, very good. Why I should not write V1 equals to E1? Anybody? Answer, please. Why I should not write V1 equals to E1? No, answer okay, minus okay. I'll tell you reason. Very good. Which is opposing? I'm asking. See, V1 is, I can take V1 as a cos here. V1 I can take it as cos. I can take E1 as a effect. or you can take I mu as a cos, because I mu is coming because of V1 in V1, you know, and I can take Ix as effect. I can take Ix as effect. Now tell me, here effect opposes cos, yes or no? Everybody respond. Effect opposing the cause, yes or no? Effect is opposing cause, yes or no? Yes, yes, very good. So to show that opposition, I am just saying minus symbol here. That's it. This minus symbol is due to what here? Lenz's law. What Lenz's law will say? What Lenz's law will say? Very simple. Effect opposes change. Effect opposes change. Effect opposes change. Is it clear, everybody? Why I wrote minus symbol here? Everybody, please respond, guys. Is it clear, everybody? Yes, yes, yes. Okay, thank you very much. Is it? I mean, tell me whether I made you easy or not. This topic I'm asking. Please tell me frankly. I made this topic easy or not? Okay, thank you, Malavika, thank you, Shanila. Remaining people, you are not. Some people are not. Always Bharat, Abjit, Shweta. Some people are responding. I don't know why. What happens to remaining people? I think they kept simply. They switched on the laptop and they went somewhere. They switched on the laptop and they went somewhere, right? Okay, right. Okay. Right. Thank you, guys. So this is that's the reason why I will write in primary side V1 bar equals to, you write what here? Minus E1 bar. It is not E1 bar. It is a minus E1 bar. Okay. And anyway, this is the reason why. Tell me, guys, why I'm just giving minus symbol? Because of Lenz's law, to show that effect. What is that effect? Effect is opposing cause. To show that effect, we are showing the minus symbol in equation. Is it clear? Now, if you really understood, tell me, remind this portion, this secondary portion, you should tell answer. Huh? You, everybody, can you please tell me answer to the secondary portion? Respond. Can you respond to the secondary portion? Yes. Let me ask question. Okay. Let me ask question. Let us once again start from. Let us start from starting onwards. Let us start. First of all, I connect voltage source V1. Because of the voltage V1, it will take some current I mu. I can say this white color current. Because of I mu, flux is produced in transformer core. So this direction of pi is coming like this. It links with the primary winding. Because of that, EMF is induced here. Okay. And that EMF direction, I mean EMF polarity also I already explained. So I told here, positive, here top side is plus, you are getting. And the bottom side, what you are getting here? Positive, you are getting here positive. You are getting here negative. So let me show here also plus, minus. This already explained. Okay, right. Now, because of this I mu, I got flux. This flux is linking with your primary winding, got EMF. So same flux going from primary to secondary, it links with the secondary winding also. Tell me, EMF will be induced, not induced in secondary winding? Tell me, EMF will be induced, not induced? Yes. So can I call that EMF as? Can I call that EMF as E2, guys? Can I call that EMF as E2? Yes, I'll call that EMF as E2. Okay. And let me ask one question. After EMF is induced, I'll repeat once again. V1 is there. Next I mu is coming. Because of V1 I mu, because of I mu flux, because of flux, you're getting EMF in secondary winding E2. If there is closed path in secondary side, yes, closed path is there or not? Respond, please. If there is closed path in secondary side, yes, I connected load. No, obviously closed path will be there. So because of this E2, you'll get some current I2. Okay. Tell me, because of current flowing in secondary side, do you get flux or not? Tell me, do you get flux or not? Tell me, do you get flux or not? Yes. I call that flux as pi 2. I call the flux as pi 2. I call that flux as a pi 2. Okay. So let me use a different color, guys. So all those is a red color for understanding 0.5. Otherwise, you'll be having some confusion. V1 I mu flux pi, E2 here. Next I2. Next pi 2. Next pi 2. Tell me. So according to Lenz's law, I think this pi 2 will oppose pi. Yes or no? Because this pi is nothing but cause here, and pi 2 is nothing but effect here. Okay, effect opposes cause, yes or no? So now tell me, that means what? So your direction of pi is downwards. This white color flux, you should see only white color flux, huh? Is downwards, upwards, huh? In this portion, direction of flux is downwards, upwards, huh? Respond. Very good. That means direction of pi 2 should be upwards, downwards, huh? Direction of pi 2 should be what? Upwards, downwards? Upwards. Very good. Upwards means like this, no? This is what I guess direction of pi 2. Upwards. Going like this, which is opposing your pi, I can call this flux as pi 2, and completing path like this. It is completing path like this. Okay, right. Now tell me, in secondary side, suppose if you want pi 2 should be upwards means, so tell me in what way I have to hold the transformer core. Image number 1 or image number 2? If you want pi 2 upwards means, okay, so tell me, or if you want simply let me ask in different way. If you want pi 2 upwards, tell me how you have to hold your core. I'm asking. Image number 1, 2. Very good, Angelus Michael. Very good. No, don't say 1. Ma. 1 means, see, you are, don't confuse. 1, those who said 1. So why you are saying 1 means in image number 1 maybe flux is upwards, but in image number 1 current is entering at front end. Okay, if current is entering at front end, then flux will be upwards. That is okay. But here, if you want direction of flux upwards means, so current has to enter at what? Back end, no? See, if it is entering here only, then only pi 2 will be upwards. In this position at back end, you have to hold your 4 fingers under this core. Please try to understand. Hold your 4 fingers under this core and hold that core. So you will get flux will be upwards. Did you get, everybody? Hold this core at this position. Then you have to hold core such that your core should be on your palm, on your hand. So your finger should be down to the core, then hold fingers, curl the fingers. So it will be upwards. Is it clear, everybody? Yes, thank you. That means upwards. So now tell me direction of I2. I'm asking now. It is entering at back end, leaving at front end, 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 leaving at front end. Yes. Current is coming like this. Tell me, guys. Always current flows at load from plus to minus or minus to plus. Current flows at load from plus to minus or minus to plus. At load, current flows from plus to minus terminal or minus to plus. Tell me. I'm waiting for your answer. Plus to minus, right? Yes. So current is this load, I can say. So current flows from plus to minus. Current is coming like this. Therefore, it becomes plus and this becomes minus. And your load voltage, I'll take it as a V2. Okay. And current is I2 path is completing like this. Okay, guys. Now, once again, please take this entire secondary winding as source like this, and tell me. Think, no problem. Just take your own time, no problem. I'm just going to leave you, but don't go anywhere. Just you can wait for 5 minutes, 2 to 3 minutes. If you skip, you cannot understand. Tell me. Please let me show this secondary winding. I can say as source like this. Okay, source. So in place of winding, let us assume that your source is there here. Source is there. The source like this. Okay. Now tell me, guys. Here you said current is entering at back end. Okay. So tell me how current is flowing from bottom to top or top to bottom. No, I'm asking. Okay. Don't tell about plus and minus. I'm asking simple question. In secondary winding, current is entering at back end, leaving at front end, entering at back end, leaving at front end, entering at back end, leaving at front end, entering at back end, leaving at front end. Tell me, current is going from bottom to top or top to bottom? Very good, nice, guys, nice. Bottom to top. That means I should indicate here. Current I2 in this manner from bottom to top I2. You know at source it is plus where from which current will leave. This is a minus, mean at which current will enter. Okay, so obviously this becomes a plus. I can say this term becomes a plus here, because this plus only I'm writing here, and this minus I'm just writing here. Okay, plus minus E2 plus minus V2. Now tell me what is the relation I can write in the secondary side, guys? Everybody, what is relation I can write in secondary side? Tell me, is it correct or not? I'm just going to write E2 bar equal to V2 bar or E2 bar equal to minus V2 bar. Is it correct what I wrote on the screen? Is it correct, or I have to write minus symbol? I think some people will be having some doubts. Sir, previously you said that V1 equals to minus E1, but here we are saying E2 equals to V2. Why you did not keep minus symbol here? Anybody give answer for that question? Anybody please tell me why I did not keep minus symbol here? Minus symbol here. Why I did not keep minus symbol here? Please respond. There is no cause effect here. See guys, very simple, everybody. If you see in the primary side, let me use laser portion, you can understand. Here, Ix is opposing I mu, no? Ix is opposing I mu. Tell me how Ix is coming because of E1. That means you are taking this one as a source. Because of that E1, you are getting Ix, which is opposing your I mu. But tell me, just like, because of V1, you are getting I mu. Because of E1, you are getting Ix. Tell me in a primary side, very good, nice answer given by somebody. Yeah. In a primary side, tell me how many sources are there ultimately? In primary side, can I take V1 as a voltage source? Can I take this entire winding as a voltage source? V1 is one voltage source, E1 is another voltage source. So because of V1 voltage source, I mu is a current. Because of V1 voltage source, Ix is the current. Which these Ix and I mu are opposing. To show that opposition only, I just keeping minus symbol here. Is it clear? Please respond. Yes or no? Yes, please respond. Yes, like that. In the secondary side, because of it is the entire winding can be taken as source. So the source voltage is E2, and because of this is E2, you are getting I2 current. Very good. Because of this E2, you are getting I2. Very good. Do you get any current because of this V2? Do you get any current because of this V2? Respond, please. Do you get any current because of this V2? No. Why? It's load voltage, is not source voltage. It is not source voltage, it's a load voltage. I don't have any current because of V2, which is opposing your I2. Just like in the primary side, Ix is opposing I mu. I don't have any current because of V2, which is opposing your I2. That's why simply E2 equals V2 only you should write. Is it clear, everybody? Everybody, is it clear? Please respond, yes or no? Yes. So guys, let me conclude for today's session. Just don't go anywhere, just 2 minutes. Okay, see, I am saying very simple question here. Everybody, in this entire session, I have given only explanation why in primary side I used to write V1 bar equals to minus E1 bar. I had given explanation, and why in secondary side E2 is equals to V2 bar I should write. This is one I had given. Okay, I hope you understood this entire discussion. No problem. Those who did not understand this concept also, V1 equals to minus E1, E2 equals to V2, how you are getting these equations, I will tell in a different way also by using waveforms in tomorrow's class. I think somebody yesterday messaged me to phone, sir, please explain V1 bar equals to minus E1 bar and E2 bar equals to V2 bar, how we are getting by using waveforms. That I'm just going to explain tomorrow. If you see those waveforms, if you are not understanding this concept also, you can understand why I wrote V1 bar equals minus E1 bar, why I wrote E2 bar equals V2 bar. So you can use this concept, or you can use the next concept which I'm just going to explain tomorrow. Okay guys, just listen. It's very important, but directions you should understand, because if it is in somewhere, it will be useful for us. Okay, in tomorrow's class, guys, don't go anywhere. See, I'll explain first of all static EMF. Everybody, are you there? Everybody, respond yes or no. Yes. See, in tomorrow's class, I'll explain static EMF. In that self-induced EMF and mutual induced EMF I'll explain. And see this bottom side one white color. Are you able to see this one? Which I this laser point you can see? Yes or no? Everybody, yes. So this is a previous question. It was the question asked GATE 1998, 1 mark. That means what I want to say is, from tomorrow onwards, we are going to solve previous gate questions. So up to today's class session, problems will not cover, only concepts only covered. But from tomorrow onwards, so concepts will be covered. So some previous questions also will come corresponding to those topics. If you see this topic, this one, and if you see guys, next topic, I'll explain about mutual individual EMF. Next, if you see, so this is the previous question asked. So that means what? I mean to say that only simple thing, from tomorrow onwards, I am just going to solve previous gate questions. So previous gate questions will come from tomorrow onwards. So for yesterday's class and today's class, I hope that problems did not come. I think you people will be feeling somewhat bored, but for solving problems which I'm just going to explain from tomorrow onwards, for solving those questions, for solving those problems, whatever the concept we explained till now, that concept is very important. Okay, is it clear? And see, suppose after explaining this question also, I'll explain EMF equation here. Okay, and I'll give some observations here. And this is the once again in this second point is the previous question asked. That also I'll explain. And after this, see this one. Are you able to see waveforms on the screen, everybody? Yes. So, I mean, V1 bar equals minus E1 bar, E2 bar equals V2 bar. How you are getting in a simple way? By using waveforms also I'll explain simply. Okay. So next, can you able to see this question? Can you able to see this question on the screen, guys? Yes. Very good. Very good. Similarly, so next I'll go for equivalent circuit of transformer no load condition. Then I'll take in this equivalent circuit of transformer no load condition. I'll explain vector diagram of transformer no load condition also. And next one, under full load condition equivalent circuit, under load condition vector diagram I'll explain. And here these are the previous questions I'll explain. Okay. Similarly, next if you see, this is the previous question once again. So why I'm showing all those things means some reason is there for that. Okay. So can I tell the reason why I'm showing all those slides which I'm just going to explain from tomorrow onwards? In advance I'm just showing those slides. Can I explain what is the reason? Can I? Yeah. Reason is simple. I think some students will be there who felt that, sir, still now we did not solve any questions, any gate questions. So we are waiting for gate questions. Like that, some people will be thinking. So for those people, I'm just going to give hint that problematic questions will be coming from tomorrow onwards. Don't miss the class from tomorrow onwards. Okay. Thank you, everybody.